She'll just have to watch the movie. All right, so we're going to do some independent events. An independent event means that you can have choice A from happening, choice B from happening, but they might have something that overlaps in the middle where they both happen at the same time. They also will talk about mutually exclusive events where you have type A and type B, but they don't ever overlap each other. If they're independent, they might overlap and you might have both occur at the same time. So first one, we are going to do the probability of A and B happening at the same time. In order to find the probability of A and B happening at the same time, we're just going to find the probability of A and multiply it by the probability of B. So it says, suppose that A and B are independent events such that P, and this when it has the bar over the top means not A, is 70%. Well, if my probability of not having A is 70%, what would be the probability of A happening? The probability is not 30%, exactly. It's not going to happen at 70%, so if I take 100% minus 70%, 30% is the probability it will happen. They told us the probability B will happen is 10%, so find the probability of A and B. We're just going to multiply those two together. So 0.30 times 0.10 would give us 0.03. The second part of that wants us to find the probability of A or B. If I'm going to find the probability of A or B, I'm going to do the probability of A plus the probability of B minus the probability of A and B. Smoosh that whole formula in there. And so to figure this one out, the probability of A was 30% plus the probability of B was 10%. I'm going to subtract the probability of A and B, which is what we found up here, 0.03 then. And I would get 0.37. So we have a 3% probability that both of them will happen, A and B, a 37% probability that either A or B will happen, in other words, both of them happening at the same time. All right, so number 2, pretty much the same thing. If I can get rid of that little deal, there we go. Suppose that A and B are independent events such that P, the probability of A not happening is 50%, so the probability of A actually happening would also be 50%, right? We want to find, first of all, the probability of A and B. So we're going to take the probability of A times the probability of B. So 0.5 times 0.2. We get 0.1. A point almost looks like a point. 0.1. A or B. Can A happen or B happen? So we have to do the probability of A plus the probability of B minus the probability of A and B. So probability of A was 0.5, probability of B was 0.2, probability of A and B was 0.1. So 0.5 plus 0.2 minus 0.1 gives us 0.6. 0.6. So on number 3, suppose that A and B are independent events such that the probability of A not happening is 10%, which means the probability of A actually happening would be 90%, so 0.90. If I'm going to find the probability of A and B, what would I do?
Yeah, you.
90 times.
We're going to multiply them. 0.90 times 0.60, right? A and B happening at the same time, we got to multiply them together. We get 0.54. If I'm going to find the probability of A or B, what would I do? Yep.
0.60 minus 0.54.
Exactly. I take the probability of A plus the probability of B, and I subtract the probability of both of them happening at the same time.
96.
And I did. I lost my answer. 0.96, okay. 0.96, good, that's what I got. All right. So A and B are going to be two events, and they give us the probability of A being 36%, the probability of B being 15%. Determine the probability of A or B, given that A and B are mutually exclusive. And then we have A or B, given that they are independent. Now we've actually already did the independent one. We're adding in the mutually exclusive. If they're mutually exclusive, they don't have anything in common. So when we do mutually exclusive, all we're going to do is the A plus the B. We don't have to subtract the AND because there's nothing in the AND section. So if they're mutually exclusive, you're just going to take the probability of A plus the probability of B. So for part A here, the probability of A is 0.36, the probability of B is 0.15, and so if I add those two things together, I'm going to get 0.51. Now the independent is what we just got done doing, only we did it in 2 steps. So we said if it's an independent event, they can have things that overlap. So you're going to take the probability of A plus the probability of B, and you're going to subtract the probability of A and B. In order to find the probability of A and B, we multiplied those two together, right? We just did it in 2 steps last time. So on this one, for part B, we're going to take the 0.36 plus the 0.15, but we're going to subtract 0.36 times 0.15. I'm going to make it an X times. And so on the previous ones, we did that in 2 steps. We figured out the second part, and then we did the part B part. Okay. 0.456. So you want to have all of your chapter 1, all your chapter 2, all your chapter 3, and all of your chapter 4 turned in for next week when we do the midterm, because I don't want to have to put zeros in for all those grades. You midterm grade wouldn't look very good if I put zeros in for all that stuff. Number 5 then, same kind of thing. First one is just going to be the mutually exclusive where they don't have anything in common. So I'm just going to take the probability of A plus the probability of B. So I'm going to have 0.47 plus 0.48. 0.95. The next ones, they call them independent events, but really that means that you can have two cases that do have something in common. So we're going to take the probability of A plus the probability of B, and then we're going to subtract the probability of both of them happening, which you take A times B. So it's going to look something sort of like that. And we're not rounding our responses, so you'll just carry it all the way out to how many ever places it shows you. 0.7244 is what you should get, yep. All right. Number 6 then, same kind of thing, but be careful. You notice on this one, they ask for the independent one first. They switched them around on you. So if I'm going to find the probability of A or B and they're independent, meaning they have something in common, how am I going to do that? Exactly. Probability of A plus the probability of B minus the probability that both of them happen. So I have to multiply those together. So we get 0.3948. Part B, this time they are mutually exclusive, meaning they don't have anything in common that we have to subtract off on the end. So we're just going to do our 0.32 plus our 0.11, right? 0.43. Okay. So independent means I have two things that could have something in common where they overlap, and I have to subtract off that probability. Mutually exclusive, they don't have anything in common. They're not going to overlap each other. So number 7 says events A and B are mutually exclusive. So if I were thinking about my Venn diagrams that we did that one week, it means that the A and the B circles are not going to be touching each other. They don't overlap. Compute the probability that A occurs but B does not. So if A is going to occur, I'm having the probability of A. But B is not going to occur. If B is not going to occur, then I would have everything outside of B. But since this is A occurs and B does not occur, it really is just where those two things overlap each other. Well, where these two things overlap each other is just in this A section here, right? So, if I'm computing the probability of A and not B, that's how I would write that. It means all I have to really do is compute the probability of A. Because if it's not B, then it's going to be A. Well, the probability of A tells us that it's 0.04. I don't have to do much math there. The next one is one that has an or. Compute the probability that either A occurs without B or B occurs without A. So again, if A is going to occur without B, or B is going to occur without A, then in this case, that's like this top one, only the probability of A, and this one would end up being only the probability of B. Since that's an or, we're going to add those two probabilities together. So the probability of A was 0.04, excuse me. The probability of B is 0.94. If I add those two probabilities together, I get 0.98 then. Number 8, events A and B are mutually exclusive again. Suppose that A occurs with a probability of 33%, B has a probability of 10%. Compute the probability that B occurs or A does not occur or both. So, when it has or, you're doing them separately. So we're finding the probability that B occurs and then the probability of A not occurring. Make my circles. So probability of B occurring would just be B. The probability that A does not occur or both would be all of this stuff over here. Since this one is an or instead of an and, like on that previous one, or means you're doing the bigger section. So in other words, I'm doing everything but the A. If I'm going to do everything but the A, I'm going to do 1 minus the A then. 1 minus the probability of A. The probability of A is 0.33. So 1 minus 0.33 would give me 0.67 for my probability that B occurs or A does not occur. If it would have been and, then it would have been a different thing. But since it's an or, I use all of it. If it would have been an and, I would have used B only. On the next one, we want to compute the probability that neither A nor B occurs. Well, if neither A nor B occurs, I want everything on the outside of the A and the B, right? So in this case, I can take 1 minus the A plus the B. So 1 minus the 0.33 plus 0.1. Something like that. 1 minus 4.3 must give us 0.57. So neither A nor B means everything but A or B. So I do 1 minus A plus B. Gives me the stuff that are not in A and B. So number 9, again, my two events are mutually exclusive, my A and my B. Compute the probability that A does not occur or B does not occur. So if A is not going to occur, you're going to have everything but the A circle, right? If B does not occur, you're going to have everything but the B circle. Since this is an or, anything that got shaded as part of my answer, what did I shade? The whole thing. So my answer is going to be 1, which is 100%, right? The whole thing got shaded in either case. If A does not occur or B does not occur, I've got the whole thing. The next one, compute the probability that either A occurs without B occurring or A and B both occur. Now, I'm going to go to the second part of this. A and B both occurring. That can never happen because A and B don't overlap. There's no middle section where those two overlap since they're mutually exclusive. So the probability of this happening is none. So really I'm just going to compute that first one. I'm going to compute the probability that A occurs without B occurring. So this is where we started with when I had A and not B. I just computed the probability of the A, right? Probability of A happening is 0.03. So again, those ones will probably take you some practice to figure out where I'm at and if it's and or, what do I include. If you haven't done the Venn diagram things, you probably want to do those first. (10, 11, and 12, we're having conditional probability. And so when they do conditional probability, they're saying, given I know this is true, what's the probability the second thing happens? At a certain college, 51% of the students are female and 19% of the students major in civil engineering. Furthermore, 10% of the students are both female and major in engineering. So what we're going to do is take the both and divide it by the one that's the given part of my problem. For example, if we look at part A, what is the probability that a randomly selected civil engineering major is female? So in this case, we know that this is the given thing. We know that they are female, and we want to find what percent are civil engineering majors. So what we're going to do is take the probability of both, which is the 10%, and divide it by the probability of the females, which was 51%. These ones we are going to round your answer to 2 decimal places. We get, what was that?
Is it
Point 20.
0?
Yep, that's what I got. Point 20. Okay. Second part of this. What is the probability that the randomly selected female student majors in civil engineering? Again, this is the given part of it. We know they major in civil engineering. We want to find which ones are female. So, again, the top number is the both. The both is 10%. The bottom number is the civil engineering, which was 19%. So I'm going to take 0.10 divided by 0.19.
0.53.
0.53. Now sometimes they're a little nicer because they use the word given right in the problem. Given that senior citizens suffer from anxiety, what is the probability that he or she also suffers from a sleep disorder? So we are going to take the both, which is 5%, divided by the given part of it. The given part of it that is that they suffer from anxiety. So the anxiety is going to go on the bottom of that first one, which is the 8%. And we would get,
1.625.
so rounding to 2 decimal places, 0.63. 1625.63. The part B of that. Find the probability that a senior citizen suffers from anxiety given that they have a sleep disorder. Both goes on top, so the both is the 5%. The sleep disorder is the given part of that, which was 92%. 92% suffer from sleep disorders, right? Rounding that off to 2 decimal places, I'm going to have 0.05 for my answer. Number 12 then, it is estimated that during the past year, 27% of all adults visited a therapist, and 44% of all adults use non-prescription antidepressants. It is also estimated that 22% of all adults both visited a therapist and used a non-prescription antidepressant during the year. Part A. What is the probability that an adult visited a therapist during the past year, given that he or she used non-prescription antidepressants? So on the top of my fraction, I'm going to use the 0.22, which is both. On the bottom of my fraction, I'm going to use the 0.44, because it was given that they use non-prescription antidepressants, which was the 44%. I end up with 0.5. I'm going to put 2 decimal places, so I'm going to use 0.50. Should take it the other way, but just in case. Second part of that. What is the probability that a randomly selected adult who visited a therapist during the past year also used non-prescription antidepressants? That one's a trickier one because it doesn't say the word given in there, right? But it's given that they visited a therapist. We want to find the ones that use the non-prescription antidepressants. So the top number is going to be our 22%. The bottom number is the percent who visited the therapist. If in doubt, it should be the opposite of the other one. So when I divide that out to 2 decimal places, I get 0.81. Probability of dependent events. This is back to kind of like we did before. We're just going to take the probability of the first thing happening times the probability of the second thing happening, and that will give us our answer, or how many ever things we happen to have on our list. It says a department store is holding a drawing to give free shopping sprees to 2 lucky customers. There are 15 customers who have entered the drawing. 4 live in the town of Gaston, 5 live in Pike, and 6 live in Wells. In the drawing, the first customer will be randomly selected at random. And then the second customer will be selected at random from the remaining customers. What is the probability that both customers selected are Gaston residents? So, first of all, my probability of picking somebody from Gaston is how many are from that town? 4 out of 15 customers. So for my first drawing, I've got a chance of getting 4 out of 15. However, once I draw one of them, now my probability is going to change. Now there are only 3 left out of 14, right? Because I picked one of them out. And so now to find the probability, I'm just going to multiply those together. These ones they are going to leave as a fraction. So you could do some simplifying. If you're using your fraction calculator, you're probably okay. If you're using the graphing one, you're going to change your answer into a fraction when you're done. I would probably just say 4 goes into here 2 times and into there 7 times, and then multiply across the bottom and the top. Oh, I can reduce some more. 3 goes into there once and into there 5 times. Now I can multiply across the bottom and the top. And I end up with 2 over 35. If you're using your fraction calculator, you probably don't have to worry about reducing. So number 14, an automobile manufacturing plant produced 30 vehicles today. 10 were sedans, 11 were vans, and 9 were trucks. The plant managers are going to choose 2 of these vehicles for thorough inspection. The first vehicle will be chosen at random. The second vehicle will be chosen from the remaining vehicles. What is the probability that the 2 sedans will be chosen? So the probability on the first one of a sedan being chosen is 10 out of 30. After I take 1 out of there, now my probability of getting a sedan will be 9 out of 29, right. Now again, I probably could do 10 out of 30 and just make that 1/3 if I'm not using my fraction calculator. And then I could do some simplifying there. 3 goes into there once and into there 3 times. And so it looks like if I multiply that and simplify, I should get 3 out of 29. Number 15, a university's leadership council is made up of 13 members. 4 are students, 5 are teachers, and 4 are deans. The newspaper reporter is planning to select 2 council members for interviews. The first member will be chosen at random. The second one will be chosen from the remaining members. What is the probability that 2 deans will be selected? So first of all, my probability of picking a dean would be 4 over 13. Then once I've picked one out, now my remaining probability would be 3 out of 12, right? And again, if you're not using a fraction calculator, you might just reduce that down to 1/4. And then you can simplify from there. 4's cancel out. And it looks like we get 1 over 13, right? If you are using your fraction calculator, you can just punch it in. 4/13 times 3/12. They never let you forget fractions. All right. Suppose that a certain college contains 59 students. Of these, 31 are sophomores, 30 are biology majors, and 12 are neither. A student is selected at random from the class. What is the probability that the student is both a sophomore and a biology major? So if I'm going to look for both a sophomore and a biology major, I'm going to take the probability that they are a sophomore plus the probability that they are a biology major and subtract the probability of both of them or happening. So what I'm doing here is on my sophomores, I have 31 out of 59. I am then going to add the probability of the biology major. The biology major, we have 30 out of 59. I'm going to subtract the probability of both. Well, here, if 12 are neither, I'm going to take the 59 minus the 12 for what my numerator is, And then, of course, the bottom's still going to be the 59 total people. If 12 are neither and I take 59 minus 12, that means I have 47 in my both range. So I'm going to take 31 59ths plus 3 59ths minus 47 59ths. Since they all have that nice common denominator, I can just add and subtract numerators, right? 31 plus 30 minus 47 gives me hopefully 14 out of 59. Part B. Now this is the thing with the given. So when I have that given that it is a biology major, what's the probability he's also a sophomore? That's the one where we had to take the probability of both divided by the probability of the given part of that. So for part B, the probability of both is the answer that we found up here in the first part on part A. 14 59ths. We're going to divide that by the probability of the given part of it. The given is that they're a biology major. So the biology majors were 30 out of 59. So I'm going to take 14 over 59 divided by 30 over 59. I'm dividing fractions. That means I can invert and multiply if I'm not using my calculator. So I would take 14 over 59 times 59 over 30. The 59s are going to cancel out. I get 14 over 30. And then, of course, I can reduce that down. So I would get 7 over 15 for my probability. So they're combining a couple things we did there into another kind of problem that has fractions. So number 17, suppose that a certain college class contains 52 students. Of these, 33 are freshmen, 30 are business majors, and 6 are neither. A student is selected at random from the class. What is the probability that the student is both a freshman and a business major? So I'm going to do the probability that they are a freshman, which would be 33 over 52, plus the probability that they're the business major, 30 over 52, and I'm going to subtract the probability of both of them happening, which is going to be the opposite of the neither happening. And so if I have 52 minus 6, we have 46 out of the 52 then. So again, since they all just have the common denominator of 52, we can take our 33 plus our 30 and subtract our 46, and we get 17 over 52, exactly. Part B, given that the selected student is a freshman, what is the probability that he is also a business major? So we do the probability of both, which is our answer for part A, 17 over 52. We divide it by the probability of the given, they are freshmen. So the probability they are a freshman, 33 out of the 52. Again, since I'm dividing fractions, I can invert and multiply. 17 over 52 times 52 over 33. And the 52s will cancel out. I don't think I can reduce that down any farther. And so it looks like I just get 17 over 33. And number 18, pretty much just like 16 and 17 were. Suppose that a certain college class contains 60 students. Of these, 29 are seniors, 32 are English majors, and 10 are neither. A student is selected at random from the class. What is the probability that they are both a senior and an English major? So in order to figure that out, what would we do? Exactly. And she got the 50 because 10 were neither, so 60 minus 10 gave her the 50. And so the seniors, 29 out of 60, English majors, 32 out of 60, the both part of that, 50 out of 60, since it's the opposite of the neither. So 29 plus 32 minus 50 gives us 11 over 60. That's going to be your probability that they're both. Part B, given that the student is a senior, what is the probability that she is also an English major? We're going to take the probability of both, which was 11 over 60, and divide it by the probability that they are a senior, right? Because it says given they are a senior, which was 29 out of 60. Again, I'm dividing fractions. I can invert and multiply that second fraction, and the 60s will cancel out, and I just get 11 over 29, which I can't reduce. Or my answer then. All right, the next ones, I can't quite get all on there, so I'm going to slide it up to here, and I'm just going to read off my paper. It says, a course in statistics is one of the most difficult at the local university. Because of this, for the past decade, the university has arranged for a teaching assistant to hold frequent discussion sessions as part of the course. Since the inception of the discussion sessions, 50% of the students enrolled in the course regularly attend the sessions. The other 50% did not. Students regularly attending the sessions have performed better than those not regularly attending. In particular, 65% of the students who regularly attended the sessions received a grade of B or higher, while only 35% of the students not regularly attending the sessions received a grade of B or higher. Let D denote the event that the randomly chosen student enrolled in the course attended the discussion sessions. The D with the bar over the top means they did not. Then B is that they received a grade of B or higher. The B with the bar over the top is that they did not. What we're basically going to do is fill out this little chart so that we have a way to rearrange what we're thinking. So, if 50% of our students did not attend the discussion sessions, how many did? The other 50%, right? I would take 1 minus that 0.5 that's down here, and so 50% did attend the discussion sessions. Same kind of thing here. These ones got a B and went to the discussion sessions. These ones did not get a B but went to the discussion sessions. We know that 35% did not get a B. What percent did get a B then? 0.65. 1 minus that 0.35, right? If 35% did not, then 65% did. So, if we're figuring out these things here with the and, we're going to multiply our two probabilities together. The probability of D was 0.5. The probability of getting a B was 0.65. So the probability of getting, or going to the discussion sessions and getting a B would be 0.5 times 0.65, which would be 0.3 what? 25? 25. The next row here, we want the probability of going to the discussions but not getting a B. So we said the probability of going to the discussions was 0.5, not getting a B was 0.35. Just going across that one times that one, right? So 0.5 times 0.35 gives me 0.175. Okay? Now we're going to do the same thing on the bottom. Here, we did not go to the discussion sessions. The probability of getting a B was 35%. So the probability of not getting a B is going to be 65% again. That's the same numbers we had up there, right? 0.65. So, the probability of not going to the discussion sessions and getting a B, 50% times the 35%. Which we did right up here, was 1.75, right? The probability of not going to the discussion sessions and not getting a B means we're going to have the 0.5 times the 0.65. 0.5 times 0.65, we already did up at the top, 0.325. This one they happen just to use a lot of the same numbers. So, once we have our chart all completed, we want to find the probability that a randomly chosen student received a grade of B or higher. If they received a grade of B or higher, it means we don't have the bar above the B, right? Which means it could be the top one. They went to the discussion sessions and got a B. Or it could be this one. They did not go to the discussion sessions and still got a B. I'm just going to add those two probabilities together. So I'm going to take 0.325 plus 0.175, and then my answer is going to be 0.5. These are going to say do not round your responses, and so we don't have to worry about how many decimal places to show 0.5. Okay? So, number 20. Recently, Hector ran for president for the local school board. Of those who voted in the election, 90% had a high school diploma, the other 10% did not. Hector got 70% of the votes of those with high school diplomas, while he only got 20% of the votes of those without high school diplomas. D is the event that the voter had a high school diploma. The D with the bar, they did not have a high school diploma. H means they voted for Hector. H with a bar means they did not vote for Hector. So again, we're going to fill out this chart, and then we'll answer the question based on what we get in our chart. Now I got to find my problem again. Where is Hector? That must be Hector there. And so, if I look here, 10% of my voters did not or do not have a high school diploma, right? What percent do have a high school diploma? .90, right? 1 minus that 0.1, 90% would have the high school diploma. So here, voted for Hector, had a high school diploma, did not vote for Hector with a high school diploma. We know 30% of these people did not vote for Hector, which means what percent did vote for Hector? 70. 1 minus 30%, 70%. So filling out the rest of this top part of the chart, if I do have a diploma and voted for Hector, I'm going to take my 90% that had a diploma times my 70% that voted for Hector. So 0.9 times 0.7 gives me 0.63, right? On the second part of that, we want the people who had a high school diploma but did not vote for Hector. So had a diploma was 90%, did not vote for Hector was 30%. So 0.9 times 0.3 gives us 0.27. Continuing on, those without a high school diploma was down here. 20% of those without a high school diploma voted for Hector. What percent did not vote for Hector? 80%. 1 minus that 0.2 gives us 0.8 or 0.80, whichever way you want to write that. So, without a high school diploma and voting for Hector, 10% did not have a high school diploma, 20% voted for Hector, so we're going to take our 0.1 times our 0.2, and we would get 0.02. Do not have a high school diploma and do not vote for Hector. Not having a high school diploma, 0.1, times not voting for Hector, which is our 0.8. 0.1 times 0.8 gives us 0.08. Once we've got our table all filled out, we can go to our question. What is the probability that a randomly chosen voter did not vote for Hector? If they did not vote for Hector, we're looking for the ones with the bar over the H, right? So here they had a high school diploma but did not vote for Hector. Here they did not have a high school diploma and did not vote for Hector. I'm going to add those two things together. So if I take 0.27 plus 0.08, I would get 0.35. All right, number 21, pretty much the same thing. I'm just going to move it up to there. It says a sports psychologist performed a study of some visualization, yep, that word right there, techniques that she developed to improve athletic performance. She used amateur golfers and amateur tennis players as participants. In her study, 60% of the participants were golfers, the other 40% were tennis players. No participant was both. The visualization technique seemed quite helpful for both the golfers and the tennis players. 65% of the golfers reported a solid improvement, and 75% of the tennis players reported a solid improvement. So G is going to be the golfer, G with a bar, not a golfer, in other words, a tennis player. The I is that they had improvement, the I with the bar did not improve. Filling in our table. We know that 60% were golfers, so what percent were tennis players or not golfers? 40. 1 minus 0.6 gives us 0.4 down there on the bottom. Of those that are golfers, we want to find out what percent improved. We know that of those who were golfers, 35% did not improve. So if 35% did not improve, what percent did? 65. 1 minus 35 gives me 65. So, if I have my golfers and improved, to figure out the percent of my golfers that improved, I would do what times what? Exactly. 0.6 were golfers, 0.65 improved. So if I take my 0.6 times my 0.65, I get 0.39. The next line here, I want my percent who were golfers but did not improve. So what times what am I going to do? Exactly. 0.6 were golfers, 0.35 did not improve. So if I multiply those together, I get 0.21. Here we've already figured out 40% were not golfers, they're the tennis players. Here, these are how many improved of those people, how many did not improve. 25% did not improve, so what percent did improve? 75%. 1 minus that 25% would be 75%, right? So if I'm going to find the percent of the people who were not golfers but did improve, I would take what times what? The 0.4 were not golfers times the 0.75 that did improve. So 0.4 times 0.75 gives me 0.3. On the last line here, those that are not golfers and did not improve. So I am going to take 0.4 times 0.25. 0.4 were not golfers, 0.25 did not improve. I'm going to multiply that together and I get 0.1. Now that I have my table filled out, what is the probability that a randomly chosen participant reported a solid improvement after using the visualization techniques? So which ones improved? What numbers are we going to use? The 0.39 and the 0.3, those both improved, right? So 0.39 plus 0.3 would give us 0.69 when I add those together, right? All right. Law of total probabilities. It says, while working for Life magazine, Archie is assigned to the Galapagos Islands to photograph a rare gigantic white turtle. The turtle can be found either on Isabella, the largest of the 16 Galapagos Islands, or on Santa Cruz, the next largest island. Many have tried to locate the giant turtle, but 89% of them have failed. In addition, 11 out of every 15 searches in the past were conducted on Santa Cruz, though only 7% of them were actually successful. Archie intends to search on Isabella. What is the probability that Archie will successfully find the turtle? Round your answer to 2 decimal places. So, first of all, it tells us here 89% of them have failed. We actually want to know how many were successful. So if 89% failed, what percent were successful? 11%. So 11% of our people are successful. That's going to be the answer that we would want to get. We are going to find that by doing the probabilities of each of these separately. We know the Santa Cruz. So it tells us on Santa Cruz, 11 out of 15 searches is what we did. Whoops, if I could write 11 out of 15. 7% of them were successful. We want to find the probability for Isabella, which we don't know. I'm just going to put a P there because I don't want to put an I because it might look like a 1. But we know that for Isabella, what did we do here? Oh, must be the rest. 4. 11 out of 15 were conducted in Santa Cruz. That means 4 out of 15 were done on the other island, right? We need to solve this mess. It wants us to round our answer to 2 decimal places, but you don't want to round off too far when you're doing your calculations. So I would carry out my calculations to maybe 4 decimal places so that you don't get rounding errors. So, first of all, let's just figure out what this number would be. If you take 11/15 times 0.07. I didn't write it down, but it'll be all right. 0.05, it came out to that exactly?
0.0513.
There, I'm going to go that far then. I'm going to carry it at least 4 places so that at the end I don't get a rounding error. Plus, if I do 4/15, 4/15 would be what as a decimal? 0.2666. I'm going to round it off to 0.2667 just to be on the safe side. I need to solve that equation. So if I'm going to solve that equation, first thing I'm going to do is
Subtract the 0.0513.
Yep. So 0.11 minus 0.0513 would be
0.0587.
equals 0.2667p, and then I'm going to divide by my 0.2667. Smush that underneath there. Now at the end we can worry about rounding off to 2 decimal places. So if you take your 0.0587 and you divide it by your 0.2667, you get 0.22. That's what we should get. All right, let's try the next one there. Archie is stranded in a war zone in the land of whatever that is. His only chance of survival is to reach Suedland, which lies 100 miles away. There are just 2 routes to Suedland. One is through the desert, the other is long and a perilous trek through the mountains. Both routes are terribly dangerous. In the past, 56% of all who tried to reach have failed. Of all attempts to reach Suedland, 36 out of every 40 were by the desert route, although the route is longer. The mountains seem to provide more success. 80% of those who attempted to reach Suedland through the mountains were successful. To save time, Archie intends to go via the desert. What are his chances of making it through to Suedland? Round your answer to 2 decimal places. So, again, we want to start out. We know that of both routes, 56% who have tried to get there failed, right? So what percent actually made it? 44, you said?
Yeah.
44. So 44% is the total that made it there. Of those are 2 situations. If I went by the desert, 36 out of 40 made it there, or tried to make it there. What percent were successful? I gotta read my problem here. Oh, it doesn't say. That's what we're trying to find. I'm gonna put my P there. That's the one I'm trying to find if I went by the desert. The second one then. What fraction would I have if 36 out of 40 went by the desert? How many went by the mountains? Only 4 did, right? 4 out of 40 went by the mountains. Of those, 80% were successful. So there's my equation that I need to solve. So 0.44 is going to equal, again, I would divide that out, and if I need to carry it out to 4 decimal places, if it's less than that, we can use less than that. But just to be safe, we want to carry it out far enough so we don't get rounding errors. 36 divided by 40 gives me 0.9. Well, that works out nice then. I don't have to carry it out any farther if it comes out to nice 0.9. Plus, we want to do 4/40ths times 80%. 0.08. All right. Now we can solve our equation. So to solve our equation, we are then going to subtract the 0.08, which gives us 0.36 equals 0.9p then, and then we're going to divide by our 0.9, and so our answer is 0.4. I'm going to put 0.40 just because it says go to 2 decimal places. I think if you put 0.4 it should still be okay, but depending on who was picky or not when they programmed. All right, one last one on this page here. Archie is taking a course in probability theory. Discussion sessions with the class, TA, teaching assistant, conflict with Archie's trip to the beach. Poor Archie. Archie has decided between attending TA sessions, which might help him do better in the probability course, and going to the beach. Archie learns that 86% of the past students who did not attend TA sessions received a grade of B or below in the class. Archie also learns that 15% of the past students received a grade of B or a grade higher than a B. After some thought, Archie decides to attend the TA sessions. Not all of his classmates share his decision. In fact, only 1 out of every 9 of his classmates attended the discussion sessions with the TA. Compute the probability that Archie will receive a grade higher than a B in the course. Round your answer to 2 decimal places. All right, so this one tells us right away in the word problem. What percent received a grade of higher than a B? 15. So we're going to use that 15%. 15% of all the past students received a grade of higher than a B. We know that 1 out of every 9 attended the TA sessions, right? The discussion sessions. We want to find his success if he goes. Which means for our other fraction, if 1 out of 9 went to the TA sessions, how many did not go to the TA sessions? If 1 out of 9 went, how many did not go? 8 out of 9, right? 8 out of 9 did not go. So of those who did not go, how many got a B or higher? We know that 86% got a grade of B or below, but we're looking for the B or higher. So what percent got a B or higher? 14%, right? So our percent here is going to be 14. There's our equation then. So we don't have to mess with fractions. We're going to change things to decimals and carry it out to at least 4 decimal places if we need to, just so we don't get rounding errors. So 1/9, if we divide that out, would be what as a decimal? 0.1111. So 0.1111p plus, we're going to do 8/9 times 0.14. One, two, four, three, you said?
Repeating.
Oh, 4 repeating. So 4, 4. That should work. We have to solve that for p, so the next thing we're going to do is
Subtract 0.1244.
subtract our 0.1244. 0.15 minus 0.1244 would give us
0.0256.
0.0256 is going to equal our 0.1111p. And then we're going to divide by that 0.1111. And then at the end we can round to 2 decimal places. When you divide that out, tells me I only need 135 more steps. I must not have been walking around enough. We get 0.23 for our answer. Okay? So this is the overall percent of success. Then we have the fraction of what they tried times the percent, the fraction what they did not try times that percent of success. All right. That should be chapter 4. Again, if you looked, I've opened up all of the chapters through chapter 5, which we're going to do next week after the midterm. But that way, if you have some catching up to do, all of those chapters are open. And you will want to try to have all of your homework from chapters 1 through 4 turned in by next week.